Hey guys, welcome back to the last concept of electrolysis, and that is called as simple cell. Word of simple cell or simple electric cell is not mentioned in a clear way in your syllabus of both 0620 and 5070, but the concept can be asked related to the reactivity of the two metals if examiner is drawing that simple cell on his own. So here I'm going to discuss a very simple idea about simple cell. It is also called as simple electric cell. That cell I have already drawn here. This simple cell is basically different from the rest of the electrolysis cases which we have studied up till now. Instead of a battery, which was the supplier of energy in rest of the cases, here we are using a voltmeter. Voltmeter is an apparatus which is used to measure the voltage, which is used to measure the difference of the potential is creating a voltage, and that voltage can be measured by this voltmeter. Okay, so there are two different reactivity metals which are attached with this voltmeter. So here in this case, we are discussing a very commonly asked simple cell called zinc and copper electric cell or zinc and copper simple cell. Okay, so here we can say that zinc is used as a one electrode, which is a more reactive electrode, which is a more reactive metal electrode, whereas copper is the other electrode, which is comparatively a weaker metal electrode, less reactive metal electrode. Okay, so here I'm just spotlighting. They both are immersed into a solution of HCl or NaCl. So there should be an electrolyte through which the ions can transfer. Here is zinc and here is copper. We already know according to the reactivity series of the metals that zinc is more reactive metal as compared to copper. Hence zinc is going to convert itself into zinc ions and two electrons. These zinc ions will be shifted into the solution. Along with the zinc ions, there are already some ions present here. What are those ions? For example, if we have taken NaCl, then there must be Na ions, there must be Cl ions, there should be H ions, and there should be OH ions as well. Okay. So water ions, H ions, and OH ions, and NaCl ions, Na plus 1 and Cl1 minus, whereas zinc ions are coming from the zinc electrode. One thing which we already know is this, that zinc ions are coming from the zinc electrode, and the electrons which are coming from the zinc electrodes are going towards voltmeter. Okay, then we can say this thing that these electrons are moving from the voltmeter to copper. Okay, next point is this, that zinc ions are formed from zinc metal. Along with the two electrons, zinc ions are becoming part of the solution, whereas electrons are not part of the solution, rather they are part of the wire. So from the wire they are going to the voltmeter, and from the voltmeter they are going to the lesser reactivity metal electrode called copper here. Okay, so now being apparently negatively charged, because copper is just inviting, copper is just receiving the electrons. The story of the bulb I'm going to discuss with you that as well, but here I'm just telling you that copper being negatively charged now. Why copper is being negatively charged now? Because it is receiving the electrons. Okay, so apparently it is, you may say, negatively charged because electrons are negatively charged particles. So now it is attracting all the positively charged ions from the electrolyte towards itself. Now it is attracting zinc ions, it is attracting hydrogen ions, it is attracting sodium ions as well. Okay. Now out of all of these, which will be the winner? Which is the ion which is getting discharged? According to the reactivity series of the metals, already we know this thing, reactivity series of the metals. We have done this reactivity series of the metal at the start of the same chapter. We know this thing that sodium ions are of higher reactivity. Okay, I can point out, I can highlight this. Sodium ions are of higher reactivity. Then we can see this thing that zinc ions are of higher reactivity as compared to the hydrogen ions. So both sodium ions and zinc ions are of higher reactivity as compared to hydrogen ions. That's why hydrogen ions are the winner to go towards and to discharge at the to go towards. All the ions will be going towards, all the ions will be attracted towards the copper electrode, but these are the hydrogen ions which will be the winner and which will show the reaction here. Okay, and what is the reaction? Hydrogen ions are now going to receive those electrons which are coming from the zinc electrode, so hydrogen ions are receiving those electrons, and as a result they are forming hydrogen gas. You can see the bubbles of the hydrogen gas are there at the copper electrode. Okay, now what will happen? If a bulb is attached with this voltmeter, the bulb will light up due to the difference of voltage, due to the voltage production, due to the difference of potential the voltage is producing, and hence the bulb will light up. Okay. Now, the brightness of the bulb is discussed in some of the papers, and what examiner is asking, higher is the reactivity difference between the two electrodes. So, for example, one electrode is lithium and one electrode is copper. Okay, so there is a big there is a big reactivity difference between lithium and copper as compared to zinc and copper. Okay, so for example, if a lithium and a copper electric cell, then the electric difference, the reactivity difference will be greater. Okay, higher will be the voltage, higher is the reactivity difference, higher will be the voltage, brighter will be the bulb, but reaction will go on very quickly. As a result, hydrogen gas will be produced very quickly, and hence this hydrogen gas is now going to cover this whole copper electrode, and now electrons are unable to approach. Now electrons cannot approach this electrode, and as a result of that, reaction cannot be carried out further. Okay, now what is the story? I am repeating the whole thing. Higher is the reactivity difference between the two electrodes, higher will be the voltage produced, brighter will be the bulb, gas molecules, gas bubbles will be formed very quickly. As a result, they are going to cover that copper electrode, and the reaction will be completed quickly as well. Okay, so this is the basic concept related to this electric cell. And opposite process can be asked as well. Instead of zinc, if we are going to take tin, for example, tin and copper, now we can see this thing that tin and copper reactivity difference is much lesser as compared to zinc and copper, and we can say this thing that tin and copper, being a very lesser reactivity difference, are going to produce a very small voltage, very smaller level of voltage, due to lesser reactivity difference. And then what will happen, the brightness of the bulb will be lesser, so we can say dimmer will be the bulb, but for longer interval of time. So they are opposite to each other. Higher is the reactivity difference, brighter is the bulb, shorter is the interval of time. Okay, lower is the reactivity difference, lower will be the voltage, dimmer will be the bulb, but for longer interval of time. So you can see this thing. If I am writing here, for example, I'm saying that magnesium and copper electric cell, zinc and copper electric cell, and then we can say that tin and copper electric cell. Okay, and we can take another example as well, and that is called as magnesium and copper. Magnesium and copper is written, magnesium and silver electric cell. Okay, so there is A, B, C, D, E. Okay, now B, C. Okay, then B, C, D. Done. Okay, now which electric cell is going to produce the highest voltage? The answer is this one will produce the highest voltage, because this has the highest reactivity difference. You can see that silver is below copper even. Okay, so the reactivity difference is getting higher. So this is producing the highest voltage, whereas this will be number one, voltage production, and this will be number two, voltage production. It will have the greater distance, but as compared to D, it has smaller distance. That's why it is number two. Then this is number three, and this is number four. We can say that higher is the voltage produced, it means higher is the reactivity difference. One way or the other, the questions can be asked, and the answers are like this. Okay, all the best to all of you. I must say this thing, that by this topic we have covered all the concepts of electrolysis. Okay, and now I'm going to start few of the past paper questions as well, related to few other topics, and then the next chapter will be uploaded as well. Thank you very much, guys. May we all have a good day. Thanks.